And welcome, viewers, to the Daily Space Weather Show. We've got fairly stable sunspot environment. We've got some issues with satellites. Extremely calm earthquake conditions, and the 7+ magnitude earthquake drought continues. And plenty more to cover. More coronal mass ejections, likely headed in Earth's direction. We'll cover it. And lots more here at the Smash News Network, least busted name. In news, that's the past 24 hours from SDO. We're going back to basics, since things are pretty basic here at the moment. So no major flares, only C-class intensifications for the past 24 hours. We'll also do a cosmic ray report today. And we'll talk about one of the most interesting objects in the entire Milky Way galaxy, the only known cosmic ray point source, Cygnus X3. We've switched over to 304 angstroms, another classic wavelength from SDO. Here is our most active sunspot group, sunspot 3599, as it moves into a setting mode in that southwestern limb. It remains by far the most active sunspot and the most likely place to see a large solar flare. There's the house favorite wavelength of the T-mass, the most active sunspot. There's the full disk view. And by the way, let us know what you think of the new branding. We've changed the branding around a little bit here once again. Some great products there available from the Redbubble shop. You can check it out in the links below this video. Pick up some Smash-O merch if you like. Thanks to everybody who has. So that's just today. That's the SDO 171 angstroms along with the colorized magnetogram. One last little glimpse here before we get into some Earth activities. Love the SDO composite views there. The 171 plus colorized magnetogram is just delectable. Quick brief look at what's going on planet Earth. We've got some volcanic eruptions happening like Sakurajima, Popocatépetl, Santiaguido, Fuego, Revenador, and also Sabancaya. As far as seismic activity goes, very low seismic activity, not just a low number of quakes, but no large quakes. The only one over a 5 magnitude was at Costa Rica early this morning at 3:47 Universal Time. There's the location and the time. It was a 5.0 magnitude quake. So very calm as far as earthquakes go. And next we'll get into some more space weather. So the 10.7 centimeter radial flux now down to 127. 127 is the current radial flux number. And for you new viewers out there, the 10.7 centimeter radial flux is directly proportional to sunspot number. So when we see a high sunspot number, we see a high radial flux and vice versa. It comes from the upper chromosphere and lower corona. That's why we made this lovely animation for your viewing pleasure. 127 is the new F107, represented by that black line right there. 127 solar flux units is the current 10.7 centimeter radial flux. Space Weather Enthusiast Dashboard is not forecasting any geomagnetic storm activity. And again, things have been calm, although there are some coronal mass ejections on the way. So not sure how NOAA missed those. We saw them. See our video from yesterday for more details about that. After all, we do it daily. That's the purpose of the Daily Space Weather Show. Next, the past 4 hours of Earth's magnetic moment from space. This is basically what a proton experiences when it arrives at Earth's magnetosphere. And that animation depicts magnetohydrodynamic pressure for the past 4 hours. Again, it's Earth's magnetic moment from space from a magnetohydrodynamic perspective. Magnetohydrodynamic pressure perspective. Next, Earth's magnetic moment from the ground. This one shows flux density. It'll show you the most likely places to see the aurora, telluric currents, induction into your power grid, etc. It's our ground magnetic perturbations map, the last 4 hours of Earth's magnetic moment from the ground level. KP index currently at 0.33. It's very calm conditions at the moment, geomagnetically speaking, and the KP index is an average of global geomagnetism. Of course, some interesting stuff going on with the electron flux, which we'll get to on our bonus feature segment. First, some solar wind stuff. So the ACE's solar wind is low density and slow speed. The Discover, same scenario. It's under 400 kilometers per second and under 4 protons per cubic centimeter. So not only diffuse, but kind of slow. So that's the current situation for solar wind. Keep in mind, folks, those spacecraft are located at Lagrangian point 1, about 1 million miles from Earth, orbiting that Lagrangian equilibrium point. Next, our GOES magnetometers, and they're pretty smooth. Here we'll show the 7-day graph to show you how consistent those have been there. Despite some minor geomagnetic storm activity, things have been chill in the outer portion of the outer Van Allen belts, where the GOES 16 and the GOES 18 make their geosynchronous orbits. Next is our top view ecliptic plane field plot. And what's the scenario with the magnetic sectors? Well, Earth remains in a North Pole magnetic sector. We may be in a South Pole one by tomorrow, but if I had to bet, I would guess that we will probably still be in a North Pole sector by tomorrow's daily space weather video. If you bring up the last image, there's the current situation. Stereo B to the left of Earth in that image, stereo A on the right of Earth, and Earth are all in a North Pole magnetic sector at the moment. Here's our line of sight field plot, which is, if I had to pick one piece of data, this one might actually be it. If I had to only look at one piece of data, because this really shows you what's going on with the solar sunspot cycle, the solar B field, which is depicted here in blue, the polar fields in green and red for south and north, and the photosphere magnetism, where sunspots occur, in grayscale. So that's the past 4 days of our line of sight field plot. And next is our line of sight coronal hole plot. So do we see consistency in the southeastern limb yet? Yesterday it was pretty chaotic, and we do see some South Pole coronal holes here popping through. So at the moment, South Pole magnetism is winning out, and that could cause, well, I'm not sure. We could see sunspots form down there in the southeast, and we'll just have to see what happens. Keep in mind there was some magnetic instability happening in the lower corona there in that southeastern limb. So your lower left of your screen there, again, some instability happening down there. And let's get to some SDO imagery. Yes. Here come coronal holes from SDO. So that's what's going on the past 24 hours, and we do have a few coronal hole setups happening there on the Earth side of the disk. Really, the story is filaments, though. We've got a massive number of filaments. We'll get to it. First, sunspots. Sunspot numbers dropping once again down to 70. Down to 70 sunspots now, folks. And we really do have to start a bunker timeshare. So we have to start a bunker timeshare because some people are spooked of an active sun. Some people are spooked of an inactive sun. So, I mean, it seems like it would be a win-win there, because the inactive sun spooked people, they can go into the bunker when the active sun spooked people are out of the bunker, and vice versa. Seems like it would be just a brilliant move. Drop us a line in the comments if you'd like to get involved in some timeshare bunker activities. It seems like yes, if you're spooked of a quiet sun, you can be in the bunker at the opposite time when your people who are spooked of a loud sun, an active sun, can go in there. Then you can come out because you're spooked of an inactive sun. You get the idea. What could possibly go wrong? Next is our flare probability monitor and scoreboard. So we're going to get to sunspots here, but first let's take a look at our chances of large solar flares, and they're by far most likely in that southwestern limb. The lower right of your screen there, the southwestern limb, is where you can expect to see large solar flares. Don't be surprised to see some. Even though we've seen largely stable sunspots down there, just their proximity to the limb increases the likelihood they'll produce an M or even X class event. So here are sunspots from SDO Continuum. Let's get it a little bit closer to sunspot 3599. Again, that is our T-mass. And let's spice it up a little bit with some 171 angstroms 60-minute running difference imagery. And we'll leave that on there and even show the magnetogram. So giving you great insight there into how the plasma orients to those magnetic field lines and how the ends of those plasma loops orient to magnetic fields down at the photosphere level. Exciting stuff from SDO. Now here we've included just a rotating field of view image just to show you how stable that sunspot has been for the past 24 hours. And there actually is a little bit of intermediate umbral growth there in between the main groups. So that actually looks like it is growing a bit. Let me go back. A little bit of umbral growth there in between. That does raise the likelihood of solar flares, so I should correct myself. There actually has been some growth of that sunspot group and an increase in magnetic complexity. Just a minor one, but that coupled with its proximity to the limb significantly increases the likelihood of an M or X class solar flare. Next, we'll move on to energetic particles and flares. Those are kind of important, right? Yeah, those are kind of important. So let's cover that next. And we do have a small spike in the proton flux. So let's take a look at that. And there is our proton flux for the past 3 days. It's back to baseline levels. Next to X-ray flux, again, the largest flare of the past 24 was just a C-class event. It was a C, one-day graph, please. It was a C, about a C6, a C5.9 approximately. So there you go. Peak flux was at 8:50 Universal Time this morning on 3/11. And before we get to a star chart, let's cut back to our... What are we doing again? Wait, I know how this works. Yeah, that's what's up. There's the 131 angstroms wavelength. And thank goodness for SDO. And we've also put together 94 angstroms. Number 1, I order you to take a number 2 on space weather channels that spout utter nonsense about space weather. Have you, too, found yourself very critical of utter nonsense and bollocks on YouTube? Well, I certainly have. And for that, we thank you. Next, moving on to a star chart. Don't shart. It's a star chart. That's what's going on overhead, over my head. And the sun is still up there in the sky, being trailed by Mercury, the Moon, and Jupiter. So it's a great time right now to view the early dusk sky. You might be able to see Mercury if they have low light pollution and a low horizon, as well as a tiny sliver of a moon just behind it. So that could make for some great imagery. And if you want to share some imagery with us, hit us up on Twitter or on Instagram. All over the internet at Smash-O-Mash. And if you're not seeing the posts, we aren't surprised. And I won't explain why at the moment, but there are some very highly explainable reasons for it. Because reasons. Anyway, here's your solar system forecast. And we hope you enjoyed New Moon. That's where things will be in 1 week. We'll be at a gibbous waxing. Right? Continuing on to our astronomy photo of the day, which is a series of moon phases. Or what is that? Oh, a full plankton moon. Yeah. Glowy plankton. All right. There's your astronomy photo of the day, apod.nasa.gov. And before we get on to our coronal mass ejection section, let's briefly talk about Cygnus X3. Okay? Cygnus X3 is one of the most interesting objects in the entire Milky Way galaxy. It's located about 32,000 light years away, farther away than the galactic core. Okay? It's in a rather distant spiral arm. So it's a little farther away than Sagittarius A star, Cygnus X3. What's interesting about it is, not only is it one of the brightest X-ray sources in the entire sky, it's also the only known cosmic ray point source. And I just want you to take a brief look at this. So let me bring this mother up on the screen, the full screen size, because if you look right in here, we've had the longest and loudest X-ray state of Cygnus X3 ever measured. It's been measured since back in 2004. And keep in mind, these are X-rays, not cosmic rays. So these are photons, not protons. So think of it like the flaring of a distant star. Again, it's at a very great distance, too, because it is, over 30,000 light years distance. And I just wanted to show you that it's been in the loudest X-ray state for the past couple of years that it's been ever. Ever. So starting around 2021, it was in this heightened X-ray state, and it has not been consistently that high ever before since it's been measured. Now, what's interesting also is that it has now dropped down to a complete baseline state. So if you look at the lower left, that is the past 30 days of Cygnus X3's X-ray output, and you can see there that it's all the way down here at the 0 line. So just to make you aware of that, again, it's the only known cosmic ray point source, and part of the reason for that is because when cosmic rays go through the galaxy and they're going around through space, they're subjected to magnetic fields, so it's very difficult to determine the source of a cosmic ray. This object has a 4.8 hour periodicity to it, and it coincides with periodicity of cosmic ray flux. Yeah, it's true. Anyway, moving on to cosmic ray reports. We're going to show several neutron monitors and other cosmic ray monitors here. So let's look at the past 30 days from Apatity. So check it out. There you go. Apatity neutron monitor the past 30 days. And let's bring it up on the big screen here. We'll full screen that, shall we? We shall. Shall we? We shall. All right, so there's Apatity, and over the past 30 days, it's almost flat. So almost level there over the past 30 days. A slight downtick, actually. Barentsburg, a more significant downtick over the past 30 days in cosmic ray flux. Now let's move to some other neutron monitors, like the Athens neutron monitor. Athens is a little bit up for the past 30 days. So a little uptick at Athens. Going further south to Mexico City. Mexico City similar to Apatity there, as it's almost flat for the past 30 days. Next we'll go way back up north to Oulu, Finland. Also flat over the past 30 days. DOMC Antarctica, flat for the past 30 days with a minor shade uptick. and DOMB looks like a downtick over the past 30 days at DOMB. So anyway, the point is, folks, we are expecting cosmic ray flux to continue to dip here for another, about 14 months, as cosmic ray flux lags solar activity by approximately 5 months. So since we aren't at solar maximum yet, you can expect cosmic ray flux to decrease for at least 10 months, but as long as maybe something like 15 months. So 10 to 15 months of expecting cosmic ray flux to continue to decline. And if you look at the bottom there, that is the past, going back to 1965. So, and you can see here that if you look at the current state of cosmic ray flux versus the last time it was this low, it is the lowest level of cosmic ray flux in 20 years. So back in 2004, as you can see on that lower line right there, 2004 is the last time we had cosmic ray flux as low as it is today. Anyway, let's move on to some more local activity. Coronal mass ejections. Those are kind of important, right? So there's what's going on, and we are seeing some halo-like eruptions here. So we are expecting there to be 2 more CMEs of earthly directed type, and we'll show you why here next. So that's 75 frames from today at George Mason University, along with difference imagery. Here is the added LASCO C3. Let's get it a little bit closer there. So we've got events mainly coming out of the Earth side of the solar disk, really. So let me advance this sort of manually. So there's one out of the southwest. That may have earthly directed components. And this one out of the northwest may also. So also this one out of the southwest at the end may have earthly directed components. Let's take a look at stereo A. Hopefully we've got the data from it today. Let's manually advance this. So there's one out of the southwest. And a second one out of the southwest. All right, that does something. So we may have as many as 3 more CMEs directed toward Earth. But it looks like 2. That's my best guess. And let's move to our custom coronagraphs. That sounds like a good idea, right? I thought so. So there are our custom coronagraphs. You've got LASCO C2 and C3 and the SDO 304 angstroms wavelength. You'll see some plasma motions on the Earth side of the disk. There's a little closer view. So you'll see some motions up here, as well as some motions down here. So yeah, it looks like at least maybe only one. Let's move in a little bit closer here. We've added 193 angstroms running difference imagery. It'll show the filaments a little bit better. I think that is 2 separate CMEs that are pretty close together. So we are expecting maybe even 3. I think there are actually 3 earthly directed CMEs there. You can expect all of those to arrive in somewhat of a rapid succession sometime later in the day on the 14th. So that's now 4 CMEs likely headed toward the Earth. None of these are major CMEs, and none of them are expected to have major geomagnetic storm components. However, if there is a very strong magnetic field, then you never know. But we don't expect to see any more than a G2 or a KP6 type geomagnetic storm from any of these. They are fairly mild coronal mass ejections. So next is our further zoom in. And you'll see really 3 separate events there. One is right up here. There's another one down here right at sunspot 3599. And then there's one more down here So the last of the three there is the least likely to have an earthly directed component. The other two are very likely to have earthly directed components. The likelihood of those impacting Earth are like 90%. The one in the south, more like about 40% of impact. 40% likelihood of impact. Next is our equatorial zoom here. Give you a little bit more detail on that. And that's it. That's all she wrote. So let's go back to one of these. There we go. That's a pretty good one. Multiple more coronal mass ejections headed in Earth's direction. So, next we'll move to filaments. And we've got a lot on the Earth side of the solar disk. So there's the grayscale imagery. We show that because it shows prominences. You can see a huge one down there in the southwestern limb. Hanging off the edge of the solar disk, prominences are just solar filaments that are overlapping the edge of the disk. And look at the size of some of these filaments. Dag. Those are some bulky filaments, folks. And let's briefly put those on the full screen. And we'll do a filament count. So let's see, we've got 1. We'll just call that 1. Here's 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So at least a dozen filaments once again on the Earth side of the disk. That is a pretty large number of filaments, wouldn't you say? Next, bonus features. These are the past couple of hours. We do have a crown prominence, which is something you can expect to see more and more of as we get up to closer and closer to solar maximum, which we are expecting around October of 2024. So it should be nothing but this level or higher for the next approximately 14 months. Continuing right along to our bonus features segment, starting out with charging hazards. And we are seeing some issues with some satellites, but at the moment, not charging hazards. We don't see surface or internal charging hazards at the moment. And next is the electron flux. And this is news, folks. This is news because the electron flux has not been up to these levels since December of 2023. So finally seeing the electron flux here bouncing back to normal levels. Now back to a normal operating range for the electron flux. If you thought the electron flux was going to cause doomsday, well, we're terribly sorry, but it hasn't caused doomsday. There's the past year, and you can see we're back to levels we haven't seen since the middle of December of last year. Here's the forecast model, and NOAA was right on with this latest forecast. We'll have to see what happens with the next one. The green boxes represent the forecast. The yellow diamonds represent the observation. Next, the layer where it's measured, the F layer. It's at about 300 kilometers of altitude. And if you're not familiar with things like temperature inversions and the penetration of electromagnetic radiation, and of course, chemical concentrations in the ionosphere, feel free to pause the video on this frame until you understand. And keep in mind, if you're viewing on a mobile device, you can zoom in 8 times using the YouTube Junkware app. So make sure you use that YouTube Junkware app. So here's the vibrational frequency, and we are seeing some kind of anomalous looking stuff going on up there. And, well, it'll become more evident to you who are not seasoned viewers of the ionosphere ionosonde when we show the anomalygram. So don't worry, we've got you covered. The point is we're seeing some big-time variations centered around the South Atlantic anomaly, which is the area over the South American continent. You might be able to see some, well, this might make a little more sense showing anomaly in megahertz from a 30-day median. So that is the weakest point in Earth's magnetosphere right there. It's over the South American continent. You can see both high and low frequency anomalies sort of hovering around that area. So a little bit of fluctuation happening there in the ionosphere. So that's usually caused by things like space weather, but it would make sense that it's caused by the sudden increase in the electron flux. Having such a low electron flux for such a long period of time. Keep in mind, again, the ionosphere F layer is at about 300 kilometers of altitude. Next, the total ionosphere, the total atmosphere, the whole atmosphere model, or the global ionosphere nowcast. That should be helpful for both GPS users as well as high-frequency radio operators. And if it's not, well, too bad. Just wait a second and we'll show the latest imagery and then move on to our meteorology segment as a value-added service. Now, of course, I realized years ago, like maybe, 15 years ago, that it's way too easy to forecast Earth weather. It's no longer a challenge to short-term forecast earthly weather, so I needed some additional challenges. Well, turns out space weather is a little bit more difficult, but it's getting easier and easier with time as we have more and more skilled people who ought to be covering space weather. All right, maybe not. Well, it's it's kind of a tight market. The space weather market, folks, it's kind of tight. So, Anyway, that's what's going on. Let's take a brief look at Sunspot 3599 since it has been gaining a little bit of magnetic complexity there. Ooh, gaining magnetic complexity. Ooh. So it's actually, is that a reverse polarity sunspot? It's actually got a leading North Pole umbra there, folks. That's kind of a reverse polarity sunspot, but yeah, I'm over it. It's nothing to get your undergarments in a bunch over, so let's just move on. There's the full disk view. And it's time for meteorology. Yeah, we like to do the meteorology segments as well as the space weather segments because it's a value-added service. A lot of people are unable to forecast the weather, so why not help them out? Anyway, got lots of anomalously cold water here in the North Atlantic. Check it out. We've got some 11 degree Fahrenheit below normal water, and that has to do with the fact that there is a low pressure that's been hanging out over that area. When you get a low pressure system hanging out over the ocean, it tends to lower the ocean temperatures. Gotcha. Anyway, that's sea surface temperature anomaly and ocean currents. We'll just show the whole planet briefly here. Now that we brought it up, we opened a can of worms. So let's keep that thing open and show the data. So there's sea surface temperature anomaly and ocean currents for the Atlantic. There's the Arctic. There's the Indian Ocean. How about the Southern Ocean? And don't forget the mighty, mighty Pacific. That's a lot of water. And here comes our regularly scheduled meteorology segment. Jet streams of the east look like this. Jet streams, now surface winds of the east. Strong low here south of the western Aleutians. Surface winds of the central world shown here. And shout out to Matteo Jorgensen for winning the Paris-Nice, an American winning a Grand Tour so early in the season. Always exciting in the sport of cycling. There is the jet stream scenario for the central world, jet streams of the west, and the surface winds. Now, normally, we would show these interactive weather satellites, but at the moment, they are down. So we ain't got no footage from those. But don't worry, we've got footage from windy.com. So there you go. There's a fantastic satellite image. And notice how those lines are getting straight, folks. That's what happens at the equinox. We're barely a week out from the equinox here at the moment. So yeah. Spring. You've almost survived another winter, oh Northern Hemisphere viewers. Windy.com, they've got a great mobile app. Here's our weather.gov map, weather.gov. If you've got weather warnings in your area, maybe head to weather.gov and check them out. We showed you the key. I think there are too many counties for us to cover, but here comes some forecasts. Pressure and precipitations first. It's the GFS 72-hour model. Accumulated positive snow depth change in inches is next. GFS 72-hour model. And all the hot air in Colorado is not going to save it from some blanketings of snow. Next is our temperature anomaly forecast in degrees Celsius. 72-hour GFS model. We show 72-hour forecasts because those are accurate. Last but not least, the culprit for the massively warm air coming to the northeast, the jet stream. Represented here by the 250 millibar winds. We are going to have a very chaotic jet stream, especially over the western portion of the country, as a convergence-divergence happens over the east. 72-hour GFS jet stream model. Again, it's barely a week until the equinox. It occurs at March 19th at 11:06 and 28 seconds p.m. Eastern Time. We'll close this thing out with lightning. And it's pretty chill as far as lightning goes. No North American lightning whatsoever. I use lightningmaps.org. Do you? And by the way, if you haven't seen the new branding, check it out. Yeah, the new branding, folks. And congratulations on realizing the channel exists. Welcome to the Smash News Network, least busted name in news. The Pacific Northwest is getting kaplastered once again, especially Washington. Yeah, Washington. It's spelled Worshington. That is Doppler radar from radar.weather.gov. We'll focus on the lower 48. And we got old images here from the satellite, so that's where we'll close things out. Anyway, that's your recap. Doppler radar. It shows vertical motion in the air column. So anyway, it's been a delight, as always, bringing you the Daily Space Weather Show. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back.